Hey, what's up, guys? Today, let's look at the Lintcode problem number 88, lowest common ancestor. So this question actually is very classic. Amazon, I know that they love these questions. So usually, you can face this questions when you are interviewing with Amazons. Okay, let's see what it is about. Given the root and two nodes in a binary tree, and we need to find the lowest common ancestor. We call it LCA of the two nodes. So the lowest common ancestor is the node with the largest depth, which is the ancestor of both nodes. So what does it mean? We have examples here. This is the tree. So we know that 3 and 5, their lowest ancestor is 4, right? Because 4 is like, their common ancestor. We just go all the way up. And the 5 and 6, their lowest ancestor is 7. And 6 and 7, their lowest ancestor is 7. Yeah. I hope you're fine with this definition, because some people may not get used to this 6 and 7, their lowest ancestor is 7. Because some people, they don't think 7 is 7's ancestor, but in our definition, it is like this. Yeah, 7 is 7's ancestor. All right, so right now, you know the definition of this LCA. Let's see how we resolve this problem. This is a trees problem, and we always have to think that every time when we face the tree problem, we will try if we can use divide and conquer, because that is really, really useful in resolving the trees issues. So let's see how to use the divide and the conquer to resolve this problem. This is our entrance, lowest common ancestor, and since this is the divide and conquer way, that means this function is like a recursive call. So we just need to have that recursive concept in our mind right now. Okay, so we're gonna take three parameters. One is the root, which the tree root, and we give two nodes, and we need to find A and B's common ancestors in this given tree. Okay, how we're gonna do this? First, we're gonna check these parameters. If this root is null, there is no need for us to doing any calculations anymore. So we just return none. And if the root is A or root is B, then we just return root. What does it mean? That means that if the two nodes, one of them is the subtree node, is the tree node, we just to say, okay, the common ancestor of A and B is the root, whoever is the root. So this is a little bit weird, because some people think that okay, cool, maybe in the left tree we search A and B, and A is the left tree's node, and here we just return A. But what if B is not in the left tree? Then we return is the A and B's common ancestor. It may be wrong. So some students, some people, they have these issues and thoughts. Actually, they're right. This could be a potential problems, but the reason we do so is that we're gonna just fix this problem in the conquer phase, right? Remember, this is divide and conquer solutions. So let's see how we divide this. Always just resolve it in the left tree and resolve it in the right tree. That's the common divide and conquer happening in the binary tree world. So we just self-calling ourselves. We just pass our left subtree, and we try to found the common ancestors, lowest common ancestors for A and B in left tree. And the same thing, we're going to just try to found their common ancestors in right tree. So we get left ancestor and right ancestor. So this is all divide part. So let's see how we conquer this. First, we're going to check that if we found common ancestor in the left tree, and also if we found one in the right tree, if both exist, That means what? You cannot just have a common ancestor in your left tree, meanwhile in your right tree, right? It does not make sense. So that means okay, cool. They're not in both trees. They're not in both subtrees. They're in the root. So root, which is the return root. Root is the common ancestor. This could happen caused by this, because if we just map one of the node as the subtree node, we just return that, but it could be wrong, so it's going to be get fixed here. Okay, so for those students they have this issues, then this is your answer. All right, so we'll check if the left ancestor is noun. Obviously the right ancestor is going to be our common ancestor. Right ancestor cannot be noun. You have to know that. If right ancestor is none, and left ancestor is going to be our common ancestor. Yeah, so this is the whole algorithm thing. Let's see how it goes. Let's run this guy. All right, great. So no problems at all. All right, so this is today's algorithm. If you like this video, then please subscribe so that you can get my latest updates. All right, thanks. Bye.